our title today, next blank page, go on Math Notebook. It says Review Multiplication Strategies. We're working on our next unit. Our next unit is pretty cool because it's really just a mix of all the things we've learned so far. So we're going to be looking at multiplication, we're going to be looking at division, we're going to be looking at addition, we're going to be looking at subtraction. But we're almost exclusively going to be using word problems because they can be tricky. I know you know how to add and subtract. I know you know how to multiply and divide. But a word problem can sometimes make that tricky because you're not sure what you're supposed to do. So that's why we're going to be revisiting our multiplication strategies just to remember what they are, and then we're getting into some word problems. Mason, will you raise your hand, fam? What's up? Quickly. Go on, I need your math notebook out, please. What are some multiplication strategies that you remember using? It's been a while since I've asked you to multiply, but what were some strategies that you remember we used?
I remember.
Emma, what was one strategy you remember?
Putting objects into groups.
Okay, so we would make groups, which were usually like circles, right? Yeah, we might use what I like to call circles and dots. Now, did you have to put dots? No. But we made some groups with our circles and our dots. Julie, what other strategies might we have to use?
Skip counting.
Definitely use some skip counting. Skip counting is what multiplication is all about. Instead of counting by ones, when we multiply, we're doing skip counting. The math language version of skip counting. What else did we learn? What were some other strategies we learned? Avery?
We could turn a multiplication equation into a division equation.
Sure. Yep. Being able to play with what's called an inverse operation, which means that if we're not really feeling multiplication, we can rearrange that problem to be a division problem that might be easier for us to solve. Sure. Marlon? That's not going to help us solve a multiplication problem. That's just going to help us when we're looking at our bar model. Anything else that we remember using? Add some.
Oh wait.
We got groups. Yeah. Rogan?
Skip counting.
We got that one. Yep. Not in multiplication, no. So what we're going to do today is we're going to look at three, I think, the biggest strategies we learned. So if you would please, we're going to make this thing a subtitle. So if you want to make it big, you can. The first strategy we're going to look at today is just multiplication language. Being able to read and understand what it means in English. Go ahead and write multiplication language as our subtitle. And then underneath that, write that equation. And I'll stop because I know that multiplication language is kind of long. So I'll give you some seconds to write that down. What does this equation mean in English? Anyone can read that and say 7 times 3, but we read it in English so we can actually think about and make a picture in our head of what that looks like. Go for it, Emma.
7 groups of 3 is the same value as.
Beautiful. 7 groups of 3. I'm going to change the same value just because it's a little longer. I'm just going to change it to worth. Same idea, it's just shorter for me to write. Is worth mystery. 7 groups of 3 is worth mystery. Great. I'm not looking for the answer, I'm looking for the language. Here's a trick. question. Don't yell it out, but I want you to think about that. Is this the same? Raise your hand and tell me. Don't yell at me. Is that the same? Lydia?
Yes.
Why?
Because you're just like. Because it's a commuter property. Like doing like you're kind of just changing up how you're putting it.
Can you read that to me in English?
3 groups of 7 is the same value as.
Is that the same as 7 groups of 3?
Yes. Yes.
Is it?
It's the same value.
It is the same value. But if I'm having a birthday party and I have 7 friends who I'm giving 3 cookies to, would I do 3 groups of 7 cookies?
No.
It gets me the same number. I still have 21 cookies or whatever it is that I'm doling out. But it's not the exact same. You read it as 3 groups of 7. That is different than 7 groups of 3. That'll look different. That'll feel different. Yes, Lydia, you're completely correct. I will get the same number of stuff. But 7 groups of 3 will be different than 3 groups of 7.
Kind of.
Maverick, what you thinking?
Why they switched it is because of commutative property.
So the commutative property says that I can switch it and end up with the same ending value. 3 groups of 7 will also equal 7 groups of 3. But they are different. So far, so good. Emma?
But the only time whenever you can't use the commutative property is with division, because then you're splitting, then you're dividing by a different.
Yeah, Emma just brought up a good point. She said, hey, we can't use commutative property in division because you'd be dividing by something completely different. And you're exactly right. Multiplication's kind of fancy that way. You get to use these fancy tricks. Circles and dots.
Oh.
This was the very first strategy we learned. Circles and dots. New subtitle. Circles and dots. Jordan, what's up, friends?
I used the whole room on my lesson.
All right, how else are you going to solve that problem? Love it.
Yep, I did too.
Circles and dots. Raise your hand to read that expression to me in English. Raise your hand to read that expression to me in English. Go for it, Marley. I don't have equals blank. I just have 4 groups of 3. 4 groups of 3. My circles. Circle the word circles. Circle the word circles. My circles are going to represent my groups. So in the equation, or sorry, the expression, 4 groups of 3, how many groups do I have? Bowen? Are you listening? Because I'm not convinced by your body that you're listening to my words. Let's try that again. In the expression, 4 groups of 3, how many groups do I have?
4.
I have 4. Go ahead and draw 4 circles.
Wow.
That word dot can really be a lot of things, but it means the stuff in each group. Put a box around the word dots? That is the stuff in each group. All right, so we've got our 4 groups. That other part, 4 groups of 3, tells me that I have 3 things in each group. Now, I could do 3 dots. I could do 3 tallies. I could do the number 3. All of those are options. The choice is yours. If you would rather do dots, live your best life. If you'd rather do numbers, live your best life. If I'm writing, you are writing. From there, you find the total. 4 groups of 3 is worth what? How much is that really worth? Raise your hand to tell me. Mason? 12. And we can check by counting, and this should be worth 12 stuffs. 12 things. No, thank you. This was the very first way we learned multiplication, drawing it all out. I love this because it matches our language. Let's go to our second strategy. If you need to turn the page, you can. This was the second strategy that we learned. Whoops. Sorry. This is the second strategy that we learned. An array. We learned some arrays. Paxton, I need you to move on from that. What is an array? Rogan, it might be hard to keep up because you're drawing pictures instead of writing notes down. Cole, what is an array?
Like dots comes in, like numbers, dots going like that way, that way.
It's not numbers and dots.
It's 22.
What? Julian?
It's like dots going like. So imagine that you have like 3 on top, and then like you have like on the left you have like 4.
We've got them in certain places. So when we make an array, we talk about these 2 words. We talk about rows and columns. I think that's what you were trying to explain to me, Julian and Cole. Rows go across the page, or if we're writing things, and columns go up and down. We're still putting things in groups. We're just now making that group look a little different. Someone raise your hand and read that expression to me, please. Ooh, that's only 2 friends can read that expression in English. Addison, go for it.
7 groups of 3.
7 groups of 3. I can arrange that as here's my 1, 2, 3, 4, 5, 6, 7. I'm going to have my rows going across, and my groups of tell me that I'm going to have 3. So here's 1, 2, 3. 1, 2, 3. With an array, it's very important that we keep our rows and columns neat, especially when we're making large arrays. It's very easy to get off count. All right, is there a reason your pencil's not in your hand, friend? I still have 7 groups of 3. I've just arranged them a little bit differently. Could my array look like this?
Yeah.
Raise your hand to tell me, and be prepared to back it up. Can my array look like that? Be There, because I'm going to ask you why. Avery?
It can look like that because of inverse operation.
Not because of inverse operation, nope. Avery is right. It can look like that, but that's not the reason why. Ava, what you think?
I think it can also go that way because you can just switch the 7 into the plus and 3 and then run with that.
Can you say that one more time, Ava? I'm sorry.
So it's kind of like right here. It's like 7 groups of 3, but you can just switch them around. It's called the commutative property.
It is. Why can we switch them around?
Because it's the same answers and it's just different ones.
It's going to give us the same value. So Ava's on the right track. I can rearrange to be 3 groups of 7. It does look different, but I can do that because my number, my value is still the same. Connor, what's up, friend?
It's rows and columns.
It is rows and columns. That's what we wrote at the top. Yep. Now, we also learned a fast array. What is a fast array? We learned about a fast array, but what was that? What was a fast array?
So, if it's 9 times 2, you would do 9 and then 2. But you wouldn't fill the rest of it.
Yeah, it's kind of like 1 row and 1 column. The other dots are there. You're just imagining them. You don't actually have to put them. Go ahead and draw a fast array for 9 times 2. When you finish, give me a secret thumb. All right, baby, you got to have your pencil in your hand, love. Go ahead and draw a fast array for 9 times 2. When you finish, give me that secret thumb. Our fast array, exactly how Lydia described it. We might do 9, going down 1, 2, 3, 4, 5, 6, 7, 8, 9. We already have 1 here, and then our next column there. Do I need to fill in the rest of it?
No.
Those dots are there, but I don't have to draw them if I know that in my brain. It's like a shortcut. It's very helpful for very large arrays. Can you actually draw that? Because what you got on your paper is not correct, friend. 9 times 2 is not a very large array. But you could use a fast array to make it even faster. Smile, get out of your desk. Right. These 2 strategies we just did, circles and dots and an array, work really well if the multiplication equation is little. It is not helpful if the multiplication equation is really big, because then I'll be drawing dots and tally marks and whatever else for forever. I don't want to do that for forever. Also, when we have really big numbers that I'm drawing, it's easy to lose track and to have to start all over. And that would be a huge bummer. So this next strategy we learned, it was really helpful for those bigger multiplication facts that are hard to skip count and would take 8,000 dots. Next strategy, if you need to turn the page, you can. Go ahead and just title it, just break apart, please. This is my favorite strategy. It's my favorite strategy because it takes harder multiplication facts and breaks them into easier, smaller ones. I like easy, smaller multiplication problems. Hard ones are hard. And if I can break apart hard ones into easy ones, I love it. So we're going to use the harder expression of 7 times 7. Maybe you have that memorized. Love that for you. Maybe you're good at skip counting by 7. Love that for you. But maybe you forgot. here's a great strategy to use. Raise your hand to read that to me in English. Go for it, Penelope.
7 groups of 7.
7 groups of 7. I'm going to chunk up those groups. Instead of doing 7 groups, I'm going to break these into easier numbers for me. What are easier numbers to maybe multiply with or skip count with than 7?
I haven't.
Dylan, what you thinking?
Before you explain what I would use for this one.
Okay, what is it? Is it break apart? Are you telling me what we're breaking apart?
No.
Oh, okay. Ava, what are we going to break it into?
We can break it into 5.
5? If I break apart 7 into 5, do I have any other pieces left over?
Yeah.
I have 2 left. I like breaking 7 into 5s and 2s because I'm so good at 5s and 2s. Give me a 2 signal if you're good at 5s and 2s. Absolutely. So now, instead of 7 groups of 7, I have 5 groups of 7. Let's write that down. 5 groups of 7. I'm going to put this in parentheses because that's its own little mini section. That's what parentheses means. Do this section first. And then next to it, I still have my 2 groups of 7. I'm going to put that in parentheses. So instead of 7 groups of 7, I've just broken it into 2 smaller equations. Eventually, it'll need to go back together. If I break apart something, it has to go back together in the end. What operation would I use to push those back together? I broke them apart, but I eventually want those 2 mini sections to get smushed back together. What math operation would I use for that? Jordan?
Addition.
Yeah, I would just add them back together. I'm going to put a little plus sign in there. So far, so far? Let's solve the first mini equation. 5 times 7. If you're not sure, start some skip counting because I know you can. All right, what you got?
35.
Love it. Underneath 5 times 7, I'm going to write 35 because I know 5 times 7 is worth 35. It's another way of writing that. Plus 2 times 7. Again, if you don't know, get those fingers going.
Fingers take longer.
Brogan?
14.
14. There's my 2 mini sections. I now need to smush them back together. 35 plus 14. When you've got that sum, raise your hand. 35 plus 14. Back that. 49. Which means my product is 49. That's what that's worth. I didn't have to draw 7 groups with 7 dots in it. I didn't have to draw 7 rows and 7 columns. I didn't have to try to skip count. We can break it into smaller equations and solve it from there. We're going to try another one. 9 times 6. I want you to solve this using the break apart strategy.
You have to break apart again.
If you want to, you can, but you do need 9 times 6. And I want you to try this problem using the break apart strategy. So, I know many of you are still working. I'm just going to offer this nugget of knowledge. I see a lot of you breaking up the 9. You are completely allowed to do that. Can you also break apart the 6?
Yes, that's what I know. Yeah?
Yes.
That's what I did.
You can break apart the 6.
You could almost break apart the 9.
You can do the 9, but it might be a little bit difficult because I imagine a lot of you broke apart the 9 into 5, super easy, love that, and 4. 4 might be the tricky. So if you're thinking, man, I'm not so sure I can do that one, why don't you try breaking up the 6 and 3?
I did 6 and 3 for 9.
You could do 6 and 3. All of that will work. How's that for you? If I was doing this, I would break up the 6. And they're definitely too easy to break up the 6. Oh,
I do it. 27.
5 and 1. I'm so good at my 5s and I am so good at my 1s.
Oh, 1.
So now I have 5 groups of 5 groups of 9. Plus 1 group of 9. 5 groups of 9, or 9 groups of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45.
What's in the 4? 54.
Plus 9. Rogan said, I broke up the 9 and I got the same answer. Yeah. I can break up the 9 and get the exact same product. Just like we talked about with commutative property. I can break it up any which way I want. And my value is still going to be the same. You can break up anything that makes your brain happy. For me, Brogan, it's easier for me to do my 5s and my 1s. But if you're like, you know what, I'm going to do my 5s and 4s or 6 and 3s or whatever, live your best life. This is where you get to choose what works for your brain. I picked breaking up the 6 because that makes my brain happy.
My brain got confused because I had 5 groups and 6.
Mm-hmm.
I counted.
Mm-hmm.
I didn't know if I was counting.
That happens. All right, we are going to be doing a lot of work with multiplication. This was a quick review. We kind of remembered some strategies we learned before. We're going to be doing a lot of work with multiplication. If you don't have your 2s memorized, your 5s memorized, or your 10s memorized, I highly recommend you get those done. You can get to any other math facts if you can get those memorized quick. Everything else we can work out, but we need some 2s, 5s, and 10s.
I used that when.
All right, we're going to stack